In this tutorial, you'll learn how to graph two linear inequalities on one coordinate plane, known as a system of inequalities. Let's get started. What you see here is an example of a system of inequalities. What do you notice? What do you wonder? Pause the video and make some observations. All right, did you ask yourself, why are there three colors? Why is one line blue? Why is one line red? Or maybe, why is one line dashed? Or maybe you remember from the previous lesson and you know why one of those lines is dashed. So you make an observation. You say, I know for the red graph that the boundary is not included in the solution set. So any point on that dashed line is not an answer. We're going to talk about this solution set today and why in our previous lesson we started writing the letter S in the shaded area. When you graph two inequalities on the same graph, the S has to be located in the double shaded region. So let's get started. Your learning target today is to solve a system of inequalities by identifying the solution set on a graph. A system of linear inequalities is when you have two or more inequalities that share the same variables. So for your level, we'll only ever be working with two inequalities. The solution set is all of the order pairs that satisfy both inequalities. Now this is a really important key vocabulary word. So if I go back to my notice and wonder picture, and I drew a point, and I drew a point in this solution area. If I asked you, how do you know the point 4, 1 is a solution to this inequality? You shouldn't say, because it's in the double shaded region. That's not the right response. 4, 1 is a solution to this system of inequalities because it satisfies both inequalities. The word satisfy means that you mathematically are true for both of the sentences. So that is an important vocabulary word that I want you to use if you are asked to describe why a certain solution is correct. You would say it satisfies both inequalities. All right, let's start graphing. Now, sometimes the graphs will be ready to go as soon as you look at them, meaning they are written in slope-intercept form. We like when they're written in this order because we can quickly identify both the slope number and the y-intercept number. So my slope number is -1 for this first equation. But remember, slope is a ratio. So if you don't have a denominator, you're going to write it in yourself. I know you can't see it there, but there are these invisible coefficients. So my green sentence, my first one, has a slope of -1 and a y-intercept of -1. And my second sentence, which I'll put a blue box around, has a slope of 1 and a y-intercept of -5. Okay, and that's important. That sign in front of it is part of its value. Now, because both of these sentences start with the letter Y, and you're probably not going to be using a marker on your paper, you're going to need to label these inequalities after you graph them. So let me show you what I mean. I'm going to clear this ink, and I'm going to get started with this first one. And for the sake of this video, I'll color code it with a green pen. So I'm going to start at -1, my y-intercept, and since my slope is -1/1, I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, right? -1 over +1. Now I can reverse my direction if I'd like. Instead of down and right, I can go up and left, up and left. The more points you can draw, the more accurate your line will be, okay? It's important that you always extend your graph all the way to the edge of the coordinate plane. This way, if you forget your arrows, I can't take off any points. So now you have to decide, should your line be dashed or should it be solid? Remember, that's determined by the inequality sign. That is a greater than sign, so that means it should be dashed. I can just leave it like these dots, or if I want, I can put a couple little dashed lines in here. But the dots are pretty close together on this inequality, so I really don't even need to try and make any dashes. Now for the shading. The shading is greater than, so if you're walking along this hill, greater than would be above your head, which is this direction. All right, now I'm going to color code my second graph in blue. Because I'm going to start a new graph, it's important that I label the one that I just finished. So right here off the grid in the lower corner, I'm going to write the name of this green graph. Y greater than negative x minus 1. If you have more than one, a label is a must. Now for the second one, my y-intercept is negative 5, and now my slope is positive 1. Again, the more points I draw, the more accurate my dashed line will be, right? This one's also a dashed line. And that's because it has a less than sign. Again, less than is lower than the line. So my solution area is the double shaded region, which is this area right over here. Don't forget to label your second graph. All right, let's try that again. The first graph, again, I'll do it in green. 1, 2, 3, 4, 5, 6, 7. Up 1, over 3. Well, that's not very many points, so I'm definitely going to want to reverse this one. Instead of up and right, I'm going to go down and left. This one is going to be a dashed line. I'm going to label it off the grid so it's not in the way. And I'm going to shade below it. Less than. Now for my second graph. A y-intercept of 4 and a slope of negative 1. Negative 1, positive 1. Negative 1, positive 1. So down and right. Down 1, right 1. Now I'm going to reverse it. And this one's going to be solid. Again, I'm going to label it off the graph. And now I'm going to think about, if I am reading the graph, where would I be walking? I would be walking down a hill, right? That would be me walking down the hill. So if the inequality is greater than, that means I would shade the area that is above my head. It would be this area here. So that makes the solution area the double shaded region. All right, the only way to make this a little bit harder is to give you an equation, or inequality I should say, that is not in slope-intercept form. So since the second one is, I'm just going to get that graph done and out of the way. So y-intercept of 1, a slope of 2. Up 2 over 1, down 2 over 1, down 2, left 1. This one is going to have a solid line because it's less than or equal to. I'm going to label my line. And I'm going to shade lower or less than. And now for the work. The first sentence needs to be manipulated or rearranged. So first I'm going to move the x to the other side. And then second, I'm going to divide by my coefficient of negative 4. Now look what's going on here. Remember, when you divide by a negative, you have to reverse the inequality symbol. And notice how with my x divided by 4, notice my negative x divided by negative 4, I filled in my invisible 1, and I reduced my negative divided by a negative to a positive. Again, I'm going to start with my y-intercept, 1, 2, 3, 4, 5, 6, negative 6, up 1 over 4, up 1 over 4, down 1 over 4, down 1 over 4. This one is also going to be a solid line. And this time I'm going to label it down here. It is greater than, so my solution area is this way. And my double shaded zone is labeled with an S. All right, one more tricky graph. What happens if you have an inequality and one of your letters is missing? That means you have one of those special lines, right? You're either horizontal or you're vertical. And if you remember correctly, anything with an X only means it only touches the X-axis. So -4 on the X-axis, and you cannot touch the Y-axis, so this is an undefined line, right? Undefined line. Now technically it's supposed to be dashed. So I'm going to put a couple dots here all the way up and down so that it looks like it's dashed, and all of these X's are -4. I'm going to label my graph, and now let's think. There's no above or below here because the line is vertical, but if the solutions are anything less than -4, then that means the solutions are over here. The second one needs a little manipulating, so I'm going to bring the 3x over to the other side. I'm going to divide by 2, and there's no reversing this time. No reversing, because I did not divide by a negative. Down 3, over 2. Down 3, over 2. Up 3, left 2. This one is also, oh, not also, this one is a solid line. The other one was not. Label your graph and choose the correct shading direction. This time it's going to be less than. So this is the correct shading area, but only this region is where the solutions are. Okay. All right. That concludes our lesson on graphing systems of inequalities.